Right, we'll do this together. Hi, it's Gadget UK here again. This time a box of 2 boards that come from Conrad over in, I think it's New Zealand actually. Yeah, 2 boards here, an A1200, I see a green pin already. Now the other thing is, and that's green, I thought I'd just show you this because look at this box, there's 2 boards in here, all the way, airmail across the other side of the world. I'd be amazed if either of these is not damaged in transit this way. There's a 1200 in here, and that's going to be the focus of the video we're looking at here now. Already I'm seeing hours and hours and hours of work here. So that's the 1200. You know what, that has actually survived. That's survived, I think. I don't really see any immediate damage there. Right, after that traumatic unboxing, everything seems to be alright. It's a Rev 1D4, so I got Kickstart 3 in here. Some yellow stuff there on top of the RAM, so this is the chip RAM. And then we got Paula, CIA I think, keyboard MCU I want to say, could be wrong. Video DAC, Lisa, Alice, hang on, that could be Gail actually, Gail and Alice I think. Yeah, 8374, that's Alice. And then, yeah, a little bit of corrosion on some of the pins in a few places. The caps are all on there, everything survived, nothing's been knocked off this. That little metal shield there was bent right out and I folded it back in and crimped it back down so it fits properly. And if I power this on, I'll show you, it is working. It's always a good thing to do when you receive something like this, just see, does it even work at the start before you do any tinkering. So switching it on, yeah, it's going to be a speed run on this, I'll keep it as short as possible. Just going to use 2 irons to remove the caps, fly around it, fit the new caps, clean it up and test it. I'll be kicking myself if this video is not under 10 minutes long. There we go, so it is working. Always a good sign. Right, so I am literally going to fly through this because I've recapped these before, and there'll be a link top right, and I'm going to time it as well, so 12:56, I won't be doing any more talking I guess until I've removed the caps. You could say 12:57 by the time I actually get to start, but I'm just going to go through these one at a time. I have to find them. Yeah, my mind is not completely on the job here properly, and we'll just try and get these off using the 2 irons technique. I haven't added any additional solder or flux to this stage, so you know what, that might hinder me. Yeah, I'm going to start doing that I think. Yeah, they definitely leaked. There's some corrosion up by the floppy power connector. 3 wires there that I'm going to plug them. They look awful. I'll show you that when we get to the point. There we go, I managed to recover that. It's going to be pretty hard, that one. And the pads were not damaged by that, so yeah, that was just lucky. What's surprising is the solder, there you go, is melting. There we go. But they're not coming off as easy as usual. Yeah, some of these ones here I'll be using Captain tape on. Yeah, so I did just trail solder in a few places here and got it over it. There we go, point there, get that off. And I'll take those through holes off before I fit the SMDs, it'll just make it easier. So of course the obvious in reverse makes sense. When you're working with 2 irons like this, just make sure you don't get your wires twisted in such a way that when you pull one iron, when you put one iron back in its stand, you pull it off. Yeah, so this one is going to be quite difficult I think. And I could just cut into the can. Lots of people do that. Do you know what? That's what I'm going to do with this one. I could be Captain tape there, it's so close to that thing. I'm going to press downwards here. Just because of its proximity to that. There we go. Pull that off if we can get that off. And the base should come off. That's it. I think one of the legs came out with that. Oh, stinks. Yeah, so pads survived alright there. So we're at 1307. So yeah, it's taking me a while, isn't it? It's not like instant removal here. Yeah, some people actually just unhook this here. You can just sort of lever out the edge a little bit. You should be able to do, in theory. There we are, pull that off. And stick it right down like that. One layer won't do it usually. You want 3 to be totally honest. That should be enough actually, because I can come in at this angle down here and then I should avoid touching anything plastic there. There we go, it keeps straight off, look. Preparation really helps. And we're at 13. So what's that about? I don't know what time it was. It's been about 15 minutes, hasn't it? 15 minutes and all the SMDs are gone. We'll use the engineer desolder pump here to remove the through holes. So let's do those. And the soldering iron came from Dermot Sweeney, by the way. Thanks ever so much to Dermot. I know he's been having a bit of a tough time recently. So yeah, massive shout out to Dermot Sweeney. Check his channel out down below. He's done some amazing stuff on Sega stuff. He's done some Sega Mega CD repairs, a number of different videos on those. Really cool videos actually. I learned things from him, if I'm honest. And some of the Sega arcade hardware as well. You know, the stuff that's based on the Dreamcast. I forget what it's called right now. Naomi. Yeah, he's got a few Naomi videos. So yeah, check out his link down below. And Dermot is similar in, well, one respect, works in the games industry, like Dennis, Retro Game Revival Dennis. But Dermot does 3D modelling stuff and graphical work, as far as I understand. But I think he does some of the game engine stuff as well, you know, I think using things like Unity and stuff. And he's knocked together a few of his own little demos and games as part of his job. But obviously, you know, he works on commercial games just like Dennis does. So yeah, we have some really interesting game dev guys in the community here that are obviously fans of this stuff just like I am. And if you're struggling, and I am a little bit here, just crank up the temperature on your solder iron. This is why a temperature controlled iron is better. I'm just giving it an extra 20 degrees there. And of course a larger tip can help, but the really small solder points on these, I don't really like using a large tip, because you can see here, you might be able to from a distance, there's loads of traces that run right next to these. You start using a giant chunky tip, you could be pressing on those, you could damage them, etc. Anyway, with an extra 20 degrees and an extra few seconds, that looks like that's come off. It's actually harder to get the through holes off than it is the SMD ones. There we go, it's started to come off and I just smeared up here, so I need to just inspect the magnifying in a minute. That's one side out. Don't pull if it's not molten. You'll know when it's molten because it's just literally just a tiny bit of pressure and it starts to move. There we go. So again, a wee bit of flux. You could crank your temperature up at this point. Right, we're at 1339. Those through holes were painful. But anyway, that's all of the caps off, so I'm just going to now just go around with a little bit of flux and braid on the pads and then do my inspection. And we'll just come in with the iron carefully, make sure we don't melt anything. That's it. Right, anyway, you get the idea. We'll just, however, just clean around that area. Right, 1357. Yeah, it's taken me ages. It's the cleaning bit. So, yeah, removing them was easy, but you can see, if you look in the light, you can see the pads. They look pretty good. Yeah. There's just a bit of corrosion up here. Yeah. We've got 3 wires at the bottom there that are a bit black. And 1 or 2 of these components around here, maybe 1 or 2 of the wires next to the cap there. So I'm just going to have a bit of a clean around with a fiberglass brush and vinegar and stuff, and then IPA before I start to fit this caps. Yeah, I am going to use a bit of vinegar actually, just because, well, it needs neutralising really. So bench has been cleaned up here, got rid of all the particles, the bits of braid, etc. And I've inspected the board, and every cap position is ready for a new cap. I don't see any particles of solder. There was a particle of solder on that little filter there. So I've got the cap kit. Yeah, he ordered this from eBay, and they're pretty good caps actually. They're all Panasonics. It's a CE series. I'll be more than up to the job though. Yeah, a couple of thousands, a couple of 470s. Someone's obviously, you know, made a correction to this and written the types and things there. Anyway, I'm just going to work through logically. I think start in this corner here. I'll get the SMD ones on and the through-hole ones down here, and then just work my way across. It's not going to take very long at all. Yeah, so the time is 14:14, actually nearly 14:15, and you can see I've just positioned the first cap. Yeah, if you use magnification, it's pretty easy to do. Just come in and try and touch the pad and not the cap. Add copious amounts of solder. I'm not going to show you all of these because you've seen it all before. There we go, that's 1 point. Remove the excess from the tip. If you need to add some additional flux, but I tend to, once removed the solder, just bob into the solder point, pull away. That's the right size now. Look, it's not too beady. Same on that side. Just give that one more go because it's still a little beady there. That's it. Right, it's 14:43. Last couple of caps, the ones here I think, and I think that's all we've got left actually. A couple of 22s. C305. That's a ceramic cap. It's actually the marking on the board. It says here where's it gone now? C305 there. That's the ceramic one. It's actually C306. So you could get confused if you know what you're looking for on here, and you're like, I need C306. You look on here, there is no C306. So I thought, oh, maybe he's mistaken. Whoever's done this kit, and they're thinking it's C305. So that's the first problem with this. The other one is, where's it gone? C21. There is no electrolyticus. There's no C21. C21's probably some ceramic or somewhere else on the board. There might not even be numbers as low as C21. So yeah, what it is again, it's the other 10. It's the two 10s that are problematic here out of the three. This one here, on the silk screen there, it says C21, and the 4 is on the very edge next to the connector here. So if you go looking for C214 against this table, you're like, there isn't a 214. What's going on? So if you're the owner of this, you know, you sell these kits, you're watching, you sell these kits, make those two changes because it's going to confuse the heck out of some people. 14:45 intermission while Gadget looks for capacitor on the floor. 14:46 capacitor found. It seems like the most pointless video ever. This, it's just like yet another recap, but it's interesting to see how long it takes me, because I have used single cotton bud on every single one as I've gone along here, so they're pretty clean already. Technically I don't even need to brush it. Where am I going here now? I'm going for these. Let's do this one. Yeah, so last and worst, this one here, the one I absolutely hate doing, and that is the last SMD cap in the kit. And if you've never watched a recap video before, well, it's not been much of a recap video this, do note these have got polarity. The can is the same shape as the white silk screen on the board. You know, there's some little angled bits on one side of it, so do get it the right way around. And on some systems there might be the odd cap that was, you know, manufactured, put on the wrong way. The silk screen may be wrong. Well, the other thing here is when you've got a really difficult scenario like this, try and place the cap best for you. So not necessarily exactly central, but where you know it's going to give you more clearance on the difficult side. So I always, on this bit here, I always put it nearer to the port at the back here. It really doesn't matter if it's not exactly central. Certainly in an area like this, because this isn't going to get knocked, is it? Oh, apart from by me alone. This is why I hate this one. I can imagine spending 20 minutes just faffing around with this one cap. And someone's bound to pipe up and say, use tweezers. How do you use tweezers when you've got solder around your hand and you've got solder? Answer that one. There's some three-handed people out there, I'm sure. Someone always says, use some tweezers. I mean, tweezers technically would work if I introduce the solder to the pad first, and then, you know, introduce the component to the solder on that pad. But anyway, that's not the way we roll. We like to make everything complicated on this channel. Final SMD solder point. Yeah, on one or two of these it's a case of squash, 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 just in order that you can, like that, get just where you need to get. Right, that will do. We'll just inspect just to make sure. Yeah, the solder points on those two there, just a wee bit beady, but anyway, that's all of the SMDs back on. Now, one or two of these don't look very straight, that one in particular, and it's just a case that it's one of those where the print's not straight on the can. So anyway, 1453, bear in mind I've cleaned every single cap as I've gone along, so that's probably added like 15 minutes or something on. I've spent 5 or 10 minutes waffling at various points, but anyway, just got these 4 to go on. Those are just going to take me about 5 or 10 minutes maybe. And the other tip I'll give you that I've covered 100 million times before. When you're desoldering the through holes, as I've done here, one's where you can, one's where you can unblock them, and that one was one where I could. Great, but one up here, I spent blooming 20 minutes or something, or 15 minutes at least trying to unblock one of the holes in there, and I gave up. It just won't unblock. When you get that situation, just press the cap onto the divots on the top side if you can. Use a bit of solder braid to, get it to sink a little bit, but you won't get all the solder out because I haven't. And then, put your cap on like that, so hit the point on the other side where it's not going through, and it will slide through. And the positive is on the left-hand side, the negative is on the right. And that kind of makes sense because looking at this, another visual clue here. If you look at that, not only can you see the positive on the right, but look at where the left side is. It's a pad joint to a massive area of copper. Now you can't always take it for granted that that would be a negative rail, but 99 times out of 100 it will be. And obviously, if you've got a scenario where you've got caps that are on negative rails, on a -12, -5, then it's going to be the cap's going to go the other way. You want the positive on the ground. So yeah, you can't always just use that as a given, but anyway, it's worth always looking at things like that. I'm just going to add a little bit of solder to that point if I can. There you go, you see that? And actually it's completely free now. The solder that was not coming out, that I spent ages and ages and ages just by doing that technique. The cap has gone on. No issues at all. Finishing up here, 1504, last capacitor to go on, and I thought I better just double check these. I've done these the way I think they're supposed to be according to the marking on the tilt screen, but we've got this retro bench guide here, from when they were around, and again these are really nice, aren't they? I've covered these a few times now. So like these, the grounds on these is the right, that's correct. On these ones here, the black is all towards the top, not a whole block. That ground there is towards the left, and black's top, and then right, left, top, right, left. And the ones over there, we got black to the top, black to the right, black to the top, black to the right. So the final one, ground to the left. So anyway, that's useful. I got my kit from them originally. I think it was one of the polymer ones. Ground to the left. And that's the only way you could improve a kit like this. Maybe is maybe FR series for these through holes. That would be better. And polymers where they are available, but don't put ceramics on. Don't recap it. I think you'll agree those solder points there look alright. So that's it. We can now power it back up and give it a try. Before we do that, there's a few other things I'm just going to do. We've got some marshmallow or something landed on the board there. I mean, it's a sticky thing, isn't it? And it did strike me that because this has come all the way from New Zealand, I think it's New Zealand, I think Conrad lives in New Zealand, and he sent me some nice things in the past. He sent me the Harlequin board, so when I did that, I think I mentioned in that video, he'd sent me that board. It was really good of him to do that. I figure, whilst it's here, I'm going to offer to fit the remaining clock port connector here, because it's missing. But I'm also going to ask him if he wants an FPU socket, because it seems a waste to have sent this all the way around the world just for a recap. We'll clean the edge connector here because, well, it just looks awful, doesn't it? Looking at the light. some marks down here and it's just a bit uneven, so yeah, Deoxit Gold. I can order some more of this in a minute. I can use some of my birthday vouchers. I've got some Amazon vouchers, so yeah, I've started ordering some spares and things I need from Amazon, which is a shame because they're rip-off prices, but you can't get eBay vouchers, so I buy a lot of stuff from eBay generally from my channel. You wouldn't believe it. You'd think DigiKey and RS and Farnell, but I mean, they can't get hold of a lot of CPLDs these days. It's actually easy to use eBay and order from China. Sadly, Deoxit is not cheap no matter where you buy it from. But yeah, I'll take advantage of using my birthday vouchers to get some more sockets and some more Deoxit. I'm alright for flux, I think, at the moment. So it's a bit uneven, that, you know, it's a bit of wear, but they're lovely and shiny now, look. And we'll try and upgrade on it in a bit, but right now I just want to just connect the power up and let's see if it still works. And yeah, the TV's on, I'll switch on, let's see if anything explodes. Please don't blow. It's a lot clearer actually, because this wasn't as noticeable before, this grey. Although it's not booting, is it? Oh yes it is, woohoo! The video's so much better. That is so much brighter. Well, there we go. So the next thing is just connect a floppy drive up, I think, boot test kit. We need to put the hood back on there, don't we? Let me just do that and switch it off, because I'll lose it otherwise probably. I mean, I'm not careless or anything, but you know, it's easy to lose things, isn't it? It went on like that. There we go. Yeah, so here's that floppy drive that I used in nearly every single video that we fixed in 2021, and it was an absolute from hell one, this. I actually recently blew up the chip there. There's a video on that as well. It might not be up yet. But this is the one that was, yeah, I had problems, it had alignment problems, it had all sorts of problems. And yeah, it works perfect. I use it day in, day out. It's had so much use, it's insane. No, it's alright, it's booting. This TV just sometimes does this, and I'm sure it's like the designers of it, Sony, went, I know, one day Gadget UK is going to buy one of these, we're going to put something in the firmware that says occasionally just don't switch it back to the AV channel, even when the AV comes on. It'll give him a heart attack, and this is what happens. There we go. It's like it forgets to automatically work with the AV stuff. It's like, what's that all about? Why does it do that? And it doesn't do it very often, it's quite rare. Yeah, and when that happens, when you just power cycle something, you're like, oh my god, why is it not booting anymore? So we've got a port missing here, haven't we? I just realised. I don't even think the mouse is going to work here, is it? And in case you're wondering what I mean, there's a connector here that goes to a little PCB that goes there, and this is the mouse port. So I don't have a mouse. That is really blooming annoying. I'm going to have to use a keyboard. Well, again, I don't have a keyboard. I've got a balked membrane that... Well, I'm just going to have to see if I can use that, aren't I? Just get a single rubber plunger and see if I can stimulate, I don't know, a key. Right, it took me ages to find that. It's one of those things where I've got a box and I thought, I'll put all my membranes in there, so there's like 6 of them. And I didn't mark any of them, so see what they are. The only reason I know this is a 1200 one, because it's got this huge ribbon here. All the others have got small, so I think they're all for 500s or something. Right, this is probably not going to work very well. I think this is the membrane, I want to say from Alex's 1200. I honestly can't honestly remember where it came from. Or whether I've got this the right way. I think I have. Yeah, because the function keys go that way. So if we push it in, there it's in. Put the hood down. Yeah, so there are faults with this. Let's just hope it's not the keys I need. We've got a bunch of plungers here for different systems. That's one from a C64 or an Amiga, I think. We could just use that to jab at this, and let's see if we can hit a function key. So let's see if we can do memory. So I think we've got what we've got. I'm looking at the 500 keyboard that's nearby. So it's the second key. Let's try that. There we go, memory. And then F1 test all memory. Let's do that. Hang on. Hard to press. There we go. So that's testing all memory. Yep, so the RAM is on first pass looking good. You really want to, you know, burn-in test something like this, really. You know, not just do one test like and go, oh, the memory's alright. You really want to leave it for running for an hour or two and just come back and go, oh, it's on round 604, it must be alright. Anyway, that's the next thing we're going to do is test the serial and parallel ports, I think. So we've got 2 of these dongles here. In this software, it actually tells you how to make one of these, which pins to join to which, you know, and obviously you need a 25-way male and a 25, sorry, that's male, and a 25 female. Yeah, and you can make one of each. And if you get the hoods, you can, have the wires inside there, and they're just nice little test dongles, aren't they? I didn't think about making a video on it, but you know what? It's not rocket science, is it? Anybody can solder a couple of wires on those. The simplest things to assemble. So I've got that one there. You can't go wrong because there's no other connector that will fit for those. The floppy drive port there's shorter. So I've got those dongles on. Let's power it back on again. Drive's alright this side, I think. The delay there is where it looks for the IDE, by the way, and we'll do serial power F9. Hang on a minute. Got to try and work out where F9 is. I think that's F9. Yep. So we'll do serial first. F1. There we go. Oh, hang on a minute. We've got a fault. So it's going to need a new 1488, I think, or something like that. Right. Let's press escape. Let's try the 1489 now. If the parallel, the parallel port. If the parallel port errors, then it probably is the 1488. Because we've seen this before. It might be the filter that's affected us as well. No, that's alright, look. What is 5 and 6? 5 is CTS. Is that clear to send? I think it is. 6 is DSR. Come on, DSR stands for now. Dial something ready. The S doesn't stand for something. I can't honestly remember what DSR is. Anyway, 5 and 6 is a problem. Let's just do CIA, so F7, so 10, 9, 7. Yeah, I'm having to count keys backwards here. That's that, CIA precision timers. Okay, that's good. That's working, isn't it? Filter, what's filter? 6, hang on. 2, 3, 6, right, I switched the filter off and on, I think. Yeah, filter's not working, is it? So we've got high pitch frequency there, pressing the filter off and on. Hang on. Not having any effect. Which is an interesting one, because I think that's the first time I've seen that on a 1200. It's going to be an SMD one, it's going to be somewhere up here, it's going to be one of these chips around here probably. I mean, I could be wrong. If something's not getting to the 1488 because of corrosion around here, that would cause both problems, wouldn't it? So maybe I should just test connectivity before I actually commit to ordering a chip and replacing it and stuff. Yeah, an SN75188. So it's the Texas Instruments one, I think. Version of the same sort of thing. But I'm sure, I have recollections that this is what you need, 4 plus 12 and minus 12 for these one or two, or one of the other of these, or both, I don't know, I can't remember which way around. So I figure, let's just check that. I looked at the schematics and lo and behold, U28, which I think is the chip in question, does need plus and minus 12 volts. So let's just measure pin 1 and pin 14. So let's just see if we have those voltages. Yeah, we've got minus 10. It's bobbing around a bit, isn't it? Maybe that minus rail's not very good on that power supply. Anyway, so the minus is there, and the positive is the other diode, I think. Is it on that side? Let's just see if that's got plus 12. Yeah, and it goes to pin 14, so it's 1, 2, 14. But why is it bobbing around? Yeah, I think it's just about ground. Remember, the ground's just like wedged in. I'm holding the ground in place. Minus 11. Looking at the positive. Plus 11. So, yeah, it's not the power supply rails there, is it? Ow, that's warm. I mean, these do get warm, but I mean, if I feel the other one, it's really hard to tell. Yeah, I would say that 1488 is getting hot. So, you know what, I'm going to go and order one. I think it's the 1488. Alright, so I've got some single inline pin header here, the right dimensions for that. I've got more of it here. It actually came from Alison Charleston, actually. Don't know what she ordered that for. But nevertheless, yeah, it was thanks to Alison we've got some of this. And I'm going to put a strip there and a strip there. I'll make sure they're obviously totally perfectly aligned with each other. We've got 1 or 2 pins to straighten on here because they got a bit bent at some point in the past. I did just check everything around here. You know, the 3 vias here, you've got like a ground, I think, plus 12, minus 12. Those go to these diodes here, and they go from the cathode side of the diode through to the VCC pins on that. And we've measured that. I've got plus 11 point summit, minus 11 point summit. This gets warm, that one doesn't. These get warm anyway. I mentioned that in a previous video. But the fact the filter's not working, I've checked every single via around here, like inspected thoroughly on both sides, measured every single cap resistor on both sides. I see no damage, and obviously the ports, the serial is this one. Yeah, how would you know that? Without looking at the case, etc. Well, it's kind of obvious. So you've got tons of decoupling and stuff here, caps and inductors and stuff. Here, it's got a few. Serial. Hardly get any connections on serial. Versus parallel that needs, you know, a lot of stuff there for the individual data bits and what have you. The other thing is, obviously, before fitting this, I asked Conrad, do you want me to fit an FPUs? Yeah, please do, brilliant. And that as well, so yeah, we'll fit those 2 things. I'll need to order another one of these. This was for my 1200, I was going to fit that to mine. Ages ago I had a theory that if you fitted an FPU, I couldn't see a reason why many of the CPU accelerators would not work with an FPU if you've got one that's not got an FPU. And you know what, that does work. One of the guys actually in the Exos forum was the first to test that, and then shortly after that Chris Edwards read that post and tried it himself, and he did a video and it worked. And then Glenn from CRG did the same thing. He did it on his TF1230, I think, and that worked. So yeah, I'm kind of late to the table, but I ordered this, kid you not, I ordered this like 18 months, 2 years before all of that stuff transpired, just based on the theory that I thought it would work. There's no reason why it wouldn't. The reason being, you see, is the decoding for this is handled by one of the chips on here. It might be Gale, I think. So you've got the decoding, even if you've got a CPU accelerator that's got decoding for an FPU on there. Yeah, but the theory behind that was, obviously this communicates with the CPU. The CPU is here. When you put an accelerator card in, this gets disabled using the CPU on here. So you then may think, well, only the CPU on here would only be able to see this. Well, it depends on the CPU card. If the CPU card's got, you know, data bus buffers and things that isolate this from seeing the data bus on the CPU, yeah, you'd have a problem. But then you've got to think, why would you do that? The only reason you'd have that issue is if you designed a CPU accelerator that deliberately had, you know, its own FPU socket on there, and you thought to yourself when you design it, I don't want it to communicate with the one on the board, I only want it to communicate with this one, therefore I'm going to kind of block the data bus side of things when we're communicating with it, and I've done the decoding myself for that. And you might actually be using the decoding from the motherboard for that anyway. You might not need decoding on the thing to get the chip select and all that, you know, the control signals that communicate, you know, allow you to communicate with that. You see what I'm trying to say? So there's no reason why it shouldn't work. And I have this theory that when I fit one of these on here, and we'll test it out, if I put my old ACA 1220 on here, I bet it works alongside the A1200. Could be wrong. I'm pretty sure the A1200 supports a coprocessor just the same. And we do know it works with the TF1230, but I mean, I can test that as well because I've got a TF1230 that we built. I think on the early boards, and this is one, it's a 1D4, is it this or something? Yeah, Commodore just never fitted the 2 connectors, they only fitted one of them, which might not be a problem, but there are some things like clock port modules and things, you know, the Amiga kit one might be like that, where, you know, you use both of them. You can see the top strip there, I have done. So yeah, the bottom strip, I'll just show you on one of these, or 2 of these. Just heat. There we go, totally unblocked. Really easy now. So that's what it was, just needed a bit more suction on the pump. Right, so that little offshoot I had there was just the right length. So yeah, the next thing we're going to do is the side that I've cut, I'm just going to file gently. And I'll stick this to the, you know, the side that presses outwards, not into the centre of the connector. It's just to make it presentable really, just to straighten up the edge. Because when you cut, you'll just get a slightly uneven edge. Yeah, so you've got a shorter side, a longer side, so the shorter side obviously goes through the PCB here. This is, and it just sticks something under it, otherwise it's not gonna go through, is it? And the other strip of pin header in with the shorter side downwards. And then obviously I need to flip it over, hold it, solder just 1 pin on each. Don't solder more than one pin at this stage when you're trying to do two strips of it like this. Maybe do a middle pin, because if you solder more than one, you're not going to be able to adjust it, and trust me, you'll probably want to adjust it when it's two separate strips like that. That's it. Ow. And it's just a case of inspecting from this side to make sure it's flat and flush and level with the other pins. But you know what? That's pretty straight. One or two of these pins need straightening, but I don't know if you can tell just looking down the profile there, it's flat with the board. And the black plastic is the thing. If you're pressing nice and evenly, it will sort of level itself, and that's what's happened with that, I think. It's just revealed though how wiggly this is here. Yeah, they're pretty bent. Look at that top row there. They sag down here a bit, and then up a bit, and then down a bit, and it's the same with these here. They're going up a bit. So that's had a bit of a knock. So I'll just need to just, once I've soldered these on, just use my thin nose pliers and just go down the profile there and straighten those. But that will deal with that. Don't press the pin whatever you do, because you know what, you can change the alignment. I think that'll do. You'll never get all the flux out from between with a cotton bud like that, which is why I'll always just tilt the board and then go like this, get a cap of IPA, and then use the toothbrush. It's hard to get those solder points looking good when they're so small like that. But anyway, that connector looks brand new. That one here is just a bit higgledy-piggledy, so I'll straighten those pins. This always happens to me. Right, I've ordered one of those for me, so I'll fit that in a little bit. But then I was just looking for something else, and I noticed I've got a drawer with line drivers on it. And I'd been looking in the miscellaneous ICs, things like op amps, stuff like that, and I couldn't find any. I'd forgotten I've got a dedicated line drivers thing, and I've got an SMD version here. I think I got these for the Terrible Fire ones, thinking I might need them when I had some issue on one of those boards at one point. We've got a 1489 and a 1488. So even though the part number's different, these are the original ones that they used on the 500 and stuff and earlier boards, and they're more reliable. The Texas Instrument ones, from my experience, run hotter. So anyway, now we've got this, let's just put it on. Why not? We're going to put this under here just to contain the heat a little bit. I'm really pleased though, because it means I might be able to just wrap this video up quickly, and I'm not waiting for that chip. Anyway, at least I'll have some spares. And as I said, the spares are just the ones that run hotter. Now, it's a bit smaller, this is the thing. This is physically small. We need to take it off anyway, so just minimising the risk of the heat going too far outwards from the hot air. Oh, hang on. I always try and get just a tiny little bit of leverage like that. Just taking its sweet time. There we go. It's off on one side, off on the other. So let's pull the heat away. Yeah, and that's cooled down for about, 2 minutes roughly. So it's still going to be a little bit warm there. Got some flux around there already. I'm going to need to cut that braid back, aren't I just hope this fixes it, and it's not like some really obscure thing like a broken trace somewhere that I can't see, or something like that. Or even a bad CIA, I don't think so though, because the timers came out okay, didn't they? The interrupts and things are okay. But you see, because the pads are wide here, you can accommodate one of these on here. Oh, hang on, it's an equivalent. It's the right one, it's the exact right part. So I'm just going to come in, touch the pad, and knock the pin. There we go. Copious amounts of solder. And we'll do the same thing. That's top left pin there, try and touch there you go, pad and not the pin, and I'll just inspect with magnification to see if it's anchored. So I'll just get some flux on there, and then on the magnification, got a bit of solder on the tip, just come in and solder from the side where you've not anchored it. So that's this left side here. Yeah, and just slide along a little bit, slowly. If you slide too fast when you drag soldering, on the side where you've just anchored one pin, it could come loose and move, do you see what I mean? So there's mileage in just leaving the pins a second or so after you've soldered them to cool and grip. PCA actually. That's it. Right, so let's just clean around there with IPA and let's give it a try. Let's hope that fixes the serial port and the filter problem. Yeah, I'll toothbrush it later, but you can see that chip's on there and the solder points aren't too bad. Pin 1 is correct as well. Right, we're all connected up again. I've got my flaky membrane and my key ready. Yeah, there we go. So serial is F1. It's really hard to get. There we go, F1. I think that's working because before we had red straight away here. There you go. Fixed. Woohoo! Thank God. That was nice and easy. We'll do parallel again, which is F2, which I think is that one. And parallel is good as well. Yay! A successful repair. Anyway, the crazy thing is with this, obviously though, it just came in for a recap. This is always what happens, and I'll be honest, this is one of the reasons why I refuse doing things for people a lot of the time. Because someone goes, can you recap my Amiga or whatever, and then I get it in and it's like, so hang on a minute, I've tested, it doesn't even work. And they're like, yeah, I figured a recap would fix it. And it's like, no, that's not how things work. If the capacitors are bad or something, 9 times out of 10, it will work. It will boot up. So if you've got a system that just doesn't work or is giving you some weird problem, it's probably not the capacitors, but the capacitors will need replacing, something like this. And this is the thing, so, you know, and then as I test things, I find faults, secondary faults, etc., things that people, you know, might not notice. I mean, has Conrad ever needed to use the parallel and serial ports here? The filter, I'll tell you what, we need to test that again, but the filter should be alright now. 6 is that one. There you go, could you hear that? Yeah, it's working. Definitely working. Goes more bassy when it's on. We'll do the tone test anyway, I think. So F5, high pitched. Sorry about the ears. There you go. Filter on, off, on, off. Right, so we need to do the final bit of testing. You know, IDE, compact flash interface, external floppy drive, and you know the expansion slot. But I figure let's get this FPU socket on. So I don't think I've ever really shown you this, but I talked about it. Yeah, what you do is get your cutters. I do it the socket end first, as near to the socket as possible, and just snip carefully into these brown pieces of plastic, little struts. Yeah, go all the way around. There's quite a few of them, and then just glue the base onto the PCB to help it stand up, so it's high enough, so the chip doesn't sink down too much, and it will be fine, it'll be reliable enough. I know some people think there's a risk there that, there you go, it's coming out that look, it might not be reliable enough that way. So, you know, we can straighten that up in a minute, remove the odd strut that's hanging on there. But you see now, we've got the socket like that, and you've got these little struts, and if you, under magnification, the best way to do this, just press the strut like that, and they just break off. They're so fragile. Careful, there we go, they just fall off. So you can see this bit here is clear now. Yeah, there you go, you can see that's not too bad. There might be the odd pin that I've accidentally touched, so when I put this on the board in a minute, I want to just make sure they're all flat and level. Now, there was a base in here, and obviously it points towards pin 1. Now that's not there, I'm left thinking, where's pin 1? I know pin 1's down here, but in terms of this socket here with the angle, yeah, I think what I need to do actually is go and get an FPU out, because if I get an FPU, I'll be able to line it up with that, I'll know where pin 1 is, and then I can correspond it to that there. Right, got some flux around there, and I'm choosing to remove the solder that's there. Just because I want it to be flat, and then it'll fit a lot better, I think. Right, so we've got the chip here, pin 1's at the bottom there, that's going to correspond with that. The slice is there, which means we need the slice here. It's going to go on like that. What's helpful is if you look at the pin 1 notch on the base, before you cut it out, just draw a little red dot on the side of the socket or something, and then you're not having to do what I'm doing. Like, that's pretty darn straight. So it's the same old thing. Yeah, so just adjusting and holding it by my hand that way. Yeah, that's that one pin soldered. It's not a big deal if it moves like when you're anchored one pin. There you go, it pulled itself into position when it hit that one pin there. So I'm pressing down, reflowing. Do the same thing over here, press down as I reflow. That's it. Inspecting all the way around, the pins look all good. Yeah, I look from above, so it's just a case now just to heat each pin one at a time with a bit of solder and flux. You could drag around there, and I might do that to get a nice clean job at the end, you know, drag the iron around with the flat tip on it. That was easy peasy. I just put some flux all around at the end and just use the Antex here because it's got, you know, hang on, I can see chisel tip, and it's just like bob in, bob out all the way along, dead easy. Bit of dragging as well, and yeah, we've got good equal size solder points. You could just, for good measure, blow down with a bit of hot air. Good solder points all around. It's like I said, the shape could look weird. You know, that's just a consequence of the angle of light and stuff, and obviously imperfections perhaps in how the pins were laid out there. But yeah, hopefully you'll agree that that is going to be resilient. So I'm so confident with that socket. The next thing I'm going to do is just snap off the bits there. That's not too bad, I don't think. And I'm going to put it the way up where we can see the pin 1 marking. So there's 4 little plastic notches there that kind of stand it off the board, but there's also ones on that side, but the arrow, importantly, is pointing down. So I have to get some rubbery glue. Yeah, and it's just like Yoo-hoo. You can see it's like a viscous, yellowy sort of thing. Hang on, get this the right way up. So I just get a blob. Hang on. Get that bubble out of the way. Oh, it's come out, look. A little blob like that, that'll do, it's more than enough. I'm just going to just liberally smear some of that around and get rid of some of it because there's probably too much. Oh, come out of the way, that's it. Yeah, the pin 1 marking's towards the bottom there, so it's just a case of just carefully sort of drop it into the position there and just move it around a bit. Do you know what, I'm pulling that back out. That glue that I just pulled off, there isn't enough. So I'm going to leave that for a few minutes now, and then we'll stick the chip in. I'll probably just test it first of all, actually, with a hard disk without anything in there. Let's do that. Yeah, I've got an Amiga kit, compact flash adapter. I've just taken the floppy out. Let's just see, is that going to boot? No. Yeah, and the issue here is it's about the compact flash card. This compact flash card is out for the TF530, so let's take that one out. I'll try another one. Right, the final idea here, we've got this. And you know what, this scares me. I don't like these. It was one of those that killed the TF534, I think, when I built that. Oh, sorry, I didn't build that. I got that from 8-Bit Dreams. Amazing German guy. So we've got to assume pin 1's right, and that says OK, you know what, so we've got to assume that I knew what I was doing. Let's just see what happens with that. That's on. Flashing. Is this going to work with the 1200? Please boot. Yes! Fantastic. We do have something that works with the 1200. So it's a basic setup here, and obviously I haven't got a mouse, but you can use, this is the nice thing with the Amiga, just trying to fold everything over here to avoid shorts. You can use the keyboard, but obviously you've got to hold multiple things down at once, haven't you? And trying to hold multiple of these down at the same time, you've got to like control shift and use the arrows or something. It's not going to happen, is it? It's not going to happen. I'm going to write on that 1200. Do you know what? I've got recollections of this is why this was set up that way, because I think I tested someone else's 1200 and they had these problems. So I'm going to write on there 1200. Right, I really like to make my life hard, don't I? I'm actually navigating here using the keyboard. I've written on there Control, Shift, Alt, A. Bear in mind this is, like I said, junk. Holding these things on like this. That's Alt, I think. And then using the direction pad and up, and then I think it's like holding that Amiga and Alt. Yeah, you could say I clicked. Now we've gone into it. There we go, and hit Fmath. Woohoo! Yeah, that's about right. Normally you'll get like 5 point something there if you're lucky. So yeah, it's just representing the correct speed roughly for a 14.3 megahertz FPU. I mean, the fact that we've booted up here is the main thing, isn't it? Everything's actually working. So I'm not going to do any more messing with that keyboard membrane. You know, all my pressing around there, it still looks good, it still looks in one piece, but of course pressing and like this on an even surface, you could damage the pads, etc. And I actually think this membrane is alright. I think I got this from somebody who replaced it, and I just trimmed the end off, and you know what, it works. And that's why I said to him, can you send me the old one? And he was like, yeah, I'll send me the old one, no worries. So it's always handy to have a membrane like that. And whilst looking at this here, something just caught my eye, it just reminded me of something funny, is that Stephen actually had a comment on here, didn't he? It says there, predicted, ignorant, EAB comment, no FPU question mark, useless, explanation mark. The thing is, it's like I say, with the 1200, you've got an FPU socket here anyway, and it works this way. So Stephen's point is totally valid there, really, that you don't even need an FPU on these, but I guess for convenience it would be nice, and that's why he's creating the TF1232. You know, not everybody wants to be bothered to take the board out and solder a socket on there. It's better, I guess, if there is something like that that has a socket. And a lot of the ones from Gens have FPUs on, in fact nearly all of them, I think. The other thing I want to do is test my 1220 with this, actually, just to see if the 1220 will work with this FPU. There's no reason why it shouldn't. It's freezing cold, that FPU, barely even lukewarm. So, you know, we could get some more speed out of it. Anyway, I'm just very pleased because, you know what, it's not just recapped, it's now serial port and filter fixed, IDE works, expansion port works, everything works. Just need to test the PCMCIA and we're pretty much done. So I think, yeah, the next thing I'm going to do probably is wait for the thing for here so I can test them out. It'll just make it a bit easier. And just test a bunch more bits of software and stuff on there. At that point we'll test the ACA1220 alongside this FPU. Yeah, and the interesting thing here is individual computers have actually disabled access, I was talking about that earlier, to the FPU on the board. You can see that there, FPU. It's not enabled it, I don't think. Anyway, I'm pleased that still works, to be honest, because it's been knocking around in the bag for quite a while. Yeah, that's the CPU card I used before I got the TF1260. Thanks to the amazing Stephen Leary, Mr. Terrible Fire. And yeah, there was, where's it going? I had this thing, yeah, in the video that covered my 12, I think it's one of the early ones on my channel. It's a bit crusty, the video. But when I did it, you can see I mounted this crystal like this just to get it off easier, because I was experimenting with different crystals, so I'm just going to leave it that way. And I removed the jumpers. That one there is not fitted on very straight, I noticed. It's not some of my best work. And this was hanging on. One wire was hanging on, the other one was disconnected, so I just put a piece of Kynar across there just to force that into 33 megahertz mode. So yeah, it's a nice card, this. And originally it had slower, I think something like a 16 megahertz 020 soldered on, and I removed it. There'll be a link top right to that video. And fitted a socket, and I got a faster 25 megahertz one and clocked it at 33. You can't go any faster than that with these. Some people would lead you to believe you can go to 40, and you can set the jumps to 40, but it just won't run. And it's not this that's not fast enough, it's the RAM, I think, because there's a direct relationship and it's about weight states. I think what you'd have to do, and I mentioned this in the video, is swap this RAM with the next model up, because you can get a faster model, and then I bet it would probably work. What did annoy me, and anybody who knows anything about this stuff is going to understand where I'm coming from, I asked Jens about this. I said, if I fit an 030 there, you've got an 030 socket, will it work? He said, I don't know, I've never tested it. That is just the most ridiculous statement ever. I think he wanted me to fail. I could be wrong, because how would you not know whether an 030 would work there? What you would know is that there's a custom firmware. So I mean, I haven't tried it because I was intelligent enough to not fall for that. I actually think that that was not a very nice way of interacting with me, if I'm honest. Could be wrong, might be a mistake. If it is, I apologise, Jens, but I'll be honest, I know you're as smart as Stephen Leary, and I know that if anybody asks you the question, could I remove this and just fit an 030 on there, will the firmware work? You'll know the answer to that, not, I don't know, I've never tested it. Yeah, unless what you really mean is, I know it probably won't work because the firmware doesn't support it because I've got a custom 030 firmware when there's an 030 on there, but I haven't tested it, so I don't know. Maybe it'll work. How would it work? It's not going to work. The bus protocol timing is going to be different between an 030 and an 020. So anyway, it was a simple question. Will an 030 work if you replace it? And I think a cryptic answer of, I don't know, I've never tested it, I've never tried it, is, not very helpful, I don't think. But anyway, that's just my opinion. Jens is a good guy. He's created lots of amazing products over the years. Yeah, but yeah, I just feel like he could be a little bit more helpful from time to time. Right, a week or two later, I have from Amiga Kit a mouse port, which I figured was a good investment because, you know, I'm bound to get one of these boards again at some point. I'm not sure which way around it goes. You can't really go too far wrong with this other than not wiring up the mouse with the right 5-volt ground connection. Could kill my mouse, but... And we don't have a mouse, so the ports run the wrong way around, so I'll just disconnect it if I can. And let's try and plug it in the other way. There we go, now we've got a mouse. So yeah, the way it was plugged in was the wrong way. Sweet. That's so much better when you've got a mouse. With this particular one is with the wires coming to the left side there. You'd think it'd be the other way because the port's on that side, but yeah, clearly not. You'd have to fold it like that in the case, I guess. Mind you, there's so much length on this, you've got no problems trying to, you know, locate it there in the Amiga. I kid you not, that took about 3 seconds to boot. Yeah, so we've got 64mm RAM. Can now go into benchmarks. Sysinfo. Yeah, there we go. FPU 6882. Let's do a speed test. Yeah, so hopefully Conrad will be pleased with that. Like I say, I can't send it back with that FPU because I think it's one of my last ones, so he can get one of those for, I don't know, about £10 probably from eBay. The main thing is it's got the socket on there. Yeah, and the FPU clock 14.3. What you could do, as I say, find where the clock goes to the FPU, cut the trace, and tap off a connection from the 28 MHz clock that I think comes from either. Yeah, I'm trying to remember what that's called now. Is it Budgie? I think it either comes from Budgie or Gale. Then it would run at 28 MHz. But as I said earlier, Glenn from CRG, he did a video on this card where he fitted one of these. And he tapped off the clock speed from the CPU here. Actually, he took the 50, I think, to there. You could do that with a wire, and as long as your FPU can do that speed, in theory it should work. But 50 on these is, yeah, a bit hit and miss. I tested that 40. A lot, you know, the ones I've got here, a lot of them I tested at 40 and they run around 40, and I got 1 or 2 that run at 50. But in order to test, you want to do more than just this. You know, if I just did some benchmarks and tests and things here, like the beach ball, for example. You may think that's sufficient to test it, but it isn't. It's not doing all the different types of functions and things that FPU is capable of doing. So you really want to, I don't know, learn a demo or something that makes use of, you know, really hammers the FPU. It doesn't really need it, but I'm going to give it a quick clean anyway here. I'm going to test the IDE speed on that SD card. I'm just interested because I can't remember if I've already done it in this video or not. Let's just see how fast it is. It should be about 1.3ish, 1.6 maybe. Yeah, 1.365, that's about right. With a faster CPU, you can get a little bit faster there, like, I don't know, if there was a 1260 in there, I'd expect it to be about 1.6 meg probably. But that can shoot up when you use the EH IDE here as well on these. That's the nice thing with the TF1230 and the TF1260. I get like 5 meg per second on my 1200 with using that interface there. Yeah, but hopefully you can see the FPU base is nice and square in there, and it's stuck down, so it just holds it the exact right height up, and it's gone on really well, hasn't it? And it's going to go back in a complimentary ESD bag here, because it came just in that cardboard box. That was it, rattling around, banging against the other board. So yeah, I'll try and package this. There's a bit of dust on that bag, look, on the top, just need to wipe that. Yeah, I'll try and package this in such a way that it has a lot of bubble wrap and stuff, and reinforce the cardboard maybe. So much discontinuity in my videos recently. I apologise if you see things out of order here. It may now look cleaner than it did when I summarise in a minute. Anyway, we've got the, and this label may not be on the board. We'll stick it there, sort of just in between these two components here, like that. So it's a wee bit crooked, that label, but yeah, recapped June 2023, and it can go back in its ESD bag and yeah, wing its way back to Conrad. So yeah, final look at the board. We dealt with that, FPU socket added, full recap, and we fixed the serial port and the filter. So I do hope you found that video interesting. Please give the video a thumbs up if you'd like to see more content like this, if you like this video. And if you'd like to support the channel, please see the Ko-fi and Patreon links down below. I will catch you in the next one.